upper extremity, which will be the topic of discussion for today. So bones of the upper extremity are bones of the pectoral girdle, the bones of the upper arm, forearm, and the hand. Please remember to subscribe the channel Jan Medi. For bones of the upper extremity, we'll start with the bones of the pectoral girdle. One scapula and one clavicle on each side makes up the pectoral girdle, which is also known as the shoulder. It's attached to the axial skeleton by sternoclavicular joint at the sternum. This is the anterior attachment of the pectoral girdle to the axial skeleton. Has no posterior attachment to the axial skeleton. That makes it having a wide range of movement. So the shoulder has a wide range of movement due to its lacking posterior attachment to the axial skeleton. Pectoral girdle primarily provides for attachment areas for numerous muscles that allows movement of the shoulder and elbow joint. Starting with the scapula, which is one of the pectoral girdle bones, we're told that it's also known as the shoulder blade. It's a triangular shaped flat bone located on the posterior thorax between levels of second and seventh ribs. So when you try to find your scapula, where it's located, be able to identify it on the posterior aspect of the thorax between second and seventh ribs. So anterior or anteriorly, the surface of scapula faces the rib cage. So anterior surface of scapula, told it faces the rib cage. Moving ahead, let's check on the anatomy of scapula. We have the first one being the scapular spine. The scapular spine is a sharp ridge of bone that runs transversely across the posterior surface of scapula, dividing the surface into two. So we will be able to identify this scapular spine just below there on the image of scapula. The first image, we have the anterior aspect of scapula and its anatomical landmarks and the grooves and the notches. Starting from A, we have the superior border of scapula. This is the superior border of scapula. Moving to B, we have the medial border of scapula. And C is the lateral border of scapula, the point where it's much far away or it's far from the midline of the body. D, the point of the arrow pointing at D, is the superior angle, while E is the inferior angle of scapula, and then F here is the lateral angle of scapula. So those are the borders of scapula, and the whole scapula has this flat surface is called the body of scapula. Moving to the numbers, we have number 1 being acromion. This is the acromion. And number 2 is the coracoid process. This is the coracoid process that extends from here to here. In number 3, we have the scapular notch. And number 5, we have the infraglenoid tubercle. That's a rigid piece of bone that's just below the glenoid cavity. Then we have number 9, which is the articular facet for acromion. So this is the articular facet for acromion, which articulates with clavicle. We'll be able to check that down below as we'll proceed with our discussion. Then we have number 10, which is the neck of scapula. This region is the neck of scapula. Then we have number 12, which is the costal surface. This region is called the costal surface or the body of scapula. On the lateral aspect of scapula, we are able to identify the acromion here, which is still number 1, the acromion just right here. Then we have number 2, which is the coracoid process right here. Then we'll talk much about this area and what's its function. We have number 5, the infraglenoid tubercle. Then we have number 7, the spine. We have number 11, which is the supraglenoid tubercle right here. And we have number 13, which is the base of coracoid process. Then we'll, however, find the lateral border denoted as C, then D, which is the superior angle, and finally E is the inferior angle of scapula. Then on the posterior surface of scapula, we have these structures, or can be able to identify the following structures. Number one as well, or as usual, is the acromion. Then number two, we have coracoid process. Sorry for some spelling mistakes, some spelling errors. That's just electronic errors. We have number two, coracoid process. Number three, we have scapular notch. We have number five, denoted as infraglenoid tubercle. Number six, we have supraspinous fossa. We'll be able to identify what's its function or what supraspinous fossa serves for. We have number seven, the spine, which we stated earlier on. Number seven, this is the spine, extension of spines, begins from here to this other end, where it becomes acromion. We have number eight, infraspinous fossa. So number six is the supraspinous fossa. Then number eight is the infraspinous fossa. Altogether, we have A as the superior border. This is the superior border. B is the medial border right here. C is the lateral border. Remember, this is the posterior aspect of scapula. We have D is the superior, D is the superior angle. E is the inferior angle. Right here is the inferior angle. F is the lateral angle, and that marks the landmarks of the scapula, or the anatomical areas of scapula. So in details, let's discuss about each anatomical marks of the scapula. So infraspinous fossa, we are told that it's a convex shaped area below the spine. From our previous, we have this infraspinous fossa. This is the infraspinous fossa, and number seven is the spine. This is now the area below the spine, which is called the infraspinous fossa. We have supraspinous fossa, a more convex shaped area above the spine. And back to our diagram, we have that donated as number six, which is the supraspinous fossa, the area just above the spine. We have subscapular fossa, a large concave depression on the anterior surface. So the costal surface or the subscapular fossa is a large concave depression on the anterior surface. The body is the main triangular portion of scapula. So the body is just the whole now portion of the scapula. Acromion. The acromion, which we just checked from the above image, which is donated as number one. This is the acromion. What's acromion? So we are told that acromion is the lateral end of the scapular spine, and this is the high point of the shoulder. This arches above the glenohumeral joint and articulates with the lateral end of clavicle at the acromioclavicular joint. So the acromion has an articulation surface which articulates with clavicle, forming this joint known as the acromioclavicular joint. We have the glenoid cavity or the glenoid fossa. This is a shallow cavity or depression located superiorly on the lateral border for articulation with the head of humerus to form glenohumeral joint, or as well known as the shoulder joint. So the glenoid cavity or the glenoid fossa is a shallow cavity that forms a glenohumeral joint when it articulates with the head of humerus. You can as well check on that. Just moving back very quickly, we can be able to identify the glenoid cavity or the glenoid fossa right here, which articulates with the head of humerus to form the glenohumeral joint or the shoulder joint. So remember, when someone mentioned about your shoulder or the shoulder joint, this forms part of the shoulder joint. Coracoid process is a hook-like projection of bone from the anterior surface of scapula and serves as the point for muscle attachment. The coracoid is just like a hook-like projection of bone. And totally we're told that it serves as an area for muscle attachment or muscles attachment. Supraglenoid tubercle, these are roughening immediately to the glenoid fossa superiorly. And this also serves as the area for some muscle attachment. Infraglenoid fossa are roughening immediately to the glenoid fossa inferiorly. So this now is found inferiorly. Just bear with me with some repetition around found here. So, but as well, provided the meaning of infraglenoid fossa, it's taken to the point, which is a roughening immediately to the glenoid fossa inferiorly. We have scapular notch, this indentation in the superior border of scapula for subscapular, suprascapular nerve. So that is the scapular notch we were able to identify from the image above. Superior border, this is the superior edge of scapula. We have medial border. This is the thin edge of scapular body near vertebral column. So this is the border just next to vertebral column. Lateral border is the thicker edge of scapular body on the lateral side. The medial border is the thin edge, while the lateral border is the thicker edge of scapular body. And for medial border is on the it's just near to the vertebral column, while the other one is far away from the vertebral column, which means in the lateral border. Superior angle is the angle formed by joining superior border and the medial border. So the angle formed by joining the superior border and the medial border brings up to the superior angle. We have inferior angle, and this is the angle formed by joining of medial and the lateral borders respectively. So the inferior border, the inferior angle, the angle formed by joining the medial and the lateral border. So that marks up the landmarks and the anatomical areas of the scapula. So we can just as well check on this diagram of these images here, which is image 2. We have the acromion, projection of the coracoid process here. We have the suprascapular notch, the indentation for suprascapular nerve. We have the glenoid cavity, which articulates the head of humerus to form glenohumeral joint or the shoulder joint. We have the lateral or the axillary border, We have the lateral or the axillary border. We have subscapular fossa around here. We have the medial border of the vertebral border. We have the superior angle around here, and then we have the superior border just right there. This is taken from the anterior view, and then we have the lateral view, the acromion, the lateral end of the spine. Then we have the spine right here. We have the glenoid cavity. We have the body. We have the infraspinous fossa, and we have supraspinous fossa. We also have this scapular notch. We have the superior border as well. We have the inferior angle right here. Moving ahead, let's check on this other bone, which is the clavicle. We told that clavicle is a long, slender S-shaped bone, also known as the collarbone. With the medial convex forward and the lateral end is concave forward. So the clavicle is the slender S-shaped bone. It's also as well known as the collarbone. Then we have the fact about the clavicle, which is medial convex forward and the lateral end is concave forward as well. So the clavicle is the first bone to ossify, which is the 5th week of gestation. And the last ossification center is the sternal end to fuse at the age of 22 to 25 years of age. So the first bone to ossify is the clavicle, and that's the 5th week of gestation. Clavicle attaches to the upper limb to the trunk. Clavicle attaches the upper limb to the trunk and also protects the underlying neurovascular structure supplying the upper limb, which is the, those are subclavian arteries and the brachial plexus. And also transmission of force from the upper limb to the axial skeleton. So clavicle is just a bone for bracing the shoulder. So those are the functions of the clavicle. as stated there. These are the images of clavicle, and this is the superior aspect of clavicle, and this other one is the inferior aspect of clavicle. Just as the scapula, the clavicle also has some landmarks and the anatomical areas. Beginning from number 11, we have the sternal end, which is the area next to the sternum. We have number 12, the articular facet for the sternum. Now here articulates with the manubrium of the sternum, form the sternoclavicular joint. Then number 13, we have the acromion end. This is the area just next to acromion of the scapula. We have 14, the articular facet for acromion, the point where it articulates with the acromion to form acromioclavicular joint. Moving to number 15, sorry, we have impression for costoclavicular ligament. This is now the impression for costoclavicular ligament. Then we have 16, conoid tubercle, which is can be seen from the inferior aspect. This is the conoid tubercle. We'll find the explanation for that as well. Then we have number 17, the trapezoid line. So this is just but an illustration of the image of the clavicle, the bony clavicle. We have another image here, the same as the one which I've just described. We have the sternal extremity, which is the medial aspect. We have the costal tuberosity. This area is the posterior aspect, and the other area is the anterior aspect. I said it's like a S-shaped. This shaped. It's a long bone as well, and the other end is the lateral end where we find the acromial extremity. This area articulates with acromion to form acromioclavicular joint. So the sternal end, in description we have a sternal end is the medial rounded end containing large facet for articulation with manubrium of sternum forming the sternoclavicular joint. The acromial end is the broad, flat lateral end of clavicle that articulates with acromion process to form AC, which is the acromioclavicular joint. Some spelling mistakes or some little spelling errors. We have conoid tubercle. Conoid tubercle is a prominence on inferior lateral end of clavicle for conoid ligament attachment or for ligamentous attachment. We have also costal tuberosity. Costal tuberosity is a rough oval on inferior medial end of clavicle for costoclavicular ligament attachment. When we'll be getting to our discussion of ligaments and muscles, we'll be able also to identify these areas such as costal tuberosity and conoid tubercle. We have trapezoid line. This for attachment point of trapezoid muscle. So we have this muscle called trapezoid muscle, and it attaches to this area known as the trapezoid line. We have the articulations of the shoulder. And the first one is glenohumeral joint. This is the ball and socket joint between glenoid fossa of scapula and the head of humerus. Just but a summary of what we've been studying. We have acromioclavicular joint. This is a gliding joint between acromion of the scapula and clavicle. Also have sternoclavicular joint. This is a gliding joint where head of clavicle fits into notch on manubrium of sternum. We have scapulothoracic joint where anterior scapula articulates with the rib. This is now just some posterior attachment of scapula to the ribs. So those are the articulation of the shoulder girdle to the axial skeleton. It's just but an image showing the articulation of these two bones, the clavicle and the scapula. This was taken from the posterior aspect. And we have this joint known as the acromioclavicular joint, right here between acromion and the clavicle. You can as well check on this glenohumeral joint here. Right here we have the glenohumeral joint. The articulation of the joint formed between the scapula and the lateral end on the head of this, the head of humerus. We'll be able to see this anatomical or the anatomy of humerus as we keep progressing. We have number 5 identified as the, number 5 is identified as the position of acromioclavicular joint, the joint which I've just stated from the above diagram. This just but shoulder girdle from superior view. So this image was taken from superior view. We have these bones, we have the sternum, which is not part of the appendicular skeleton. I just had to point out as number 3, but the bones which we are much discussion is the clavicle, which is right here, S-shaped bone. We have the scapula and the posterior aspect of the thorax, and the rest are just but the bones of the axial skeleton. We have the thoracic vertebrae, we have the ribs around here, and we have the costal, and these are the costal cartilages around here. So this is the articulation. Number 10 is the articulation of the clavicle, the sternum, which forms the sternoclavicular joint. The number 11, we have the acromioclavicular joint as well. So moving to the bones of the upper arm, we have, upper arm is also known as the brachium, which extends from the shoulder to the elbow. So the bone which extends right away from the shoulder to the elbow is known as the brachium. The brachium contains only single bone, which is the humerus. So the bone that extends from the shoulder to the elbow is known as the humerus. Humerus is the longest bone of the upper extremity, and just as other bone, it has its own anatomy. Let's check on the anatomy of the humerus. We have the head, and the head is the rounded surface articulating with the glenoid fossa. So that's the one which I've just shown you from the above images. The head of the humerus articulating. This is the head of humerus articulating with glenoid fossa of scapula, forming the glenohumeral joint. So let's proceed. We have anatomic neck. These are grooved distal to the head of humerus. We'll be able to see them right below. Greater tubercle. These are lateral projection distal to neck and serves as a site for muscle attachment. So the tubercle is the site for muscle attachment. We have the anatomy, just the anatomy of the humerus before we proceed to much and detailed part of the humerus. We have number 1 being the greater tubercle, number 2 is the lesser tubercle, and we have number 3 right here. This is the crest for lesser tubercle. We have number 4, which is the crest for greater tubercle. We have number 5, which is the intertubercular sulcus. We'll be able to find them in detail. We have number 6 right here. Sorry for not mentioning, but this is just the extension. It's just called the surgical neck of humerus. We'll be able to find it down there. Sorry for not presenting right here. We have number 7, deltoid tuberosity. We have number 8, named as anterolateral surface of the humerus. We have number 9 right here, lateral supracondylar ridge. Then number 10, we have radial fossa. This is the radial fossa right here. Remember this, the anterior surface of humerus. We have number 12, capitulum. This is the capitulum. We'll find out more about that. We have number 13, the head of humerus. Sorry. We have number 14, the anatomical neck. This is the anatomical neck. Sorry for not mentioning this. It's just but a surgical neck of humerus. We have number 15, anteromedial surface of humerus. We have number 16, which is the medial supracondylar ridge. We have number 17, which is the coronoid fossa, right here. We have number 18, which is the medial epicondyle, and 19 is the trochlea of humerus. Let's now check on these landmarks of these surface marks of the humerus and what are their main function. So sorry, let's just proceed with the image first of all. So we have number 2 as well, as we talked about the lesser tubercle, number 13 being the head of humerus, and number 14 the anatomic neck, which we also have number 6, which is the surgical neck right here. Sorry, the surgical neck. We have number 16 medial supracondylar ridge, just above the supracondyle. We have number 18 medial epicondyle. So this is the medial epicondyle. Finally, we have the posterior surface of humerus. Beginning from number 1, we have the greater tubercle, which can be seen from the posterior aspect of the humerus. We have number 13 is the head of humerus. We have number 14 is the anatomical neck of humerus. We have number 6 right there is the surgical neck of humerus. We have number 22, which is the groove for radial nerve here. These are just but a spiral groove for radial nerve. We have number 20, which is the posterior surface of humerus. We have number 23 right here, which is the olecranon fossa. We'll be able to identify that, and we shall check much in advance or in detail about that. And number 11 is the lateral epicondyle. Remember, number 18 is the medial epicondyle. Then number 11 is the lateral epicondyle. We have number 19. This is the articular surface of the humerus. Number 19 is the articular surface of humerus. So let's proceed to the description. This is just for the same image, just trying to illustrate the surface of humerus. The head, the surgical neck, the anatomical neck, the lesser tubercle, the greater tubercle, the deltoid tuberosity, the shaft, we have the capitulum, and we have the trochlear. So it's just but the same image on this. So the lesser tubercle is anterior projection of bone and also serves for muscle attachment. The lesser tubercle. Remember, we have the greater tubercle as well. Serves at the site for muscles attachment, the muscle attachment. Intertubercular sulcus. This is the bicipital groove, or the groove between the greater and lesser tubercle. The long head of biceps branchiatal runs through this groove. So the bicipital or bicipital groove, or the intertubercular sulcus, is just but a groove between the greater and the lesser tubercle, and the head of bicep branchiae runs through this groove. The edges of the intertubercular sulcus is also known as the lip. We have the surgical neck. These are constricted portion distal to the two portion and area named so for being vulnerable to fracture. So it's just but a constricted distal portion where it's so much and vulnerable to fracture. So, and the name donates it as a surgical neck. So we have the shaft. The shaft is the diaphysis of the arm bone. So the diaphysis is the shaft. We have the deltoid tuberosity, and this is a roughened V-shaped area on the lateral area of the shaft. So the deltoid tuberosity is just but a V-shaped on the lateral. Mark the area which is lateral and not medial. So it's the lateral area, and it's roughened, whereby we have this deltoid muscle attaching right there. So we also have medial and lateral epicondyle. These are raised areas on distal humerus just above the condyle. So the medial condyle is larger and protects the ulnar nerve that passes posteriorly through the ulnar sulcus. So these are just but the raised area, and as well as other raised areas of the bones, it also serves as the point for muscles attachment. We have medial and lateral condyles. These are the distal end of humerus, mainly for articulation with the forearm bones to form the elbow joint. So the condyles are sides. They're just but areas for articulation with other bones, or with forearm bones for this case, which makes up the joint. And for this case, we have the elbow joint. We have the trochlear. Let's learn about the trochlear. So trochlear is the medial condyle and looks like a pulley which articulates with ulna. So trochlear specifically articulates with ulna and the medial aspect. Then you have the capitulum, is the lateral rounded part which articulates with the head of radius. So the capitulum now articulates with the head of radius, or the trochleus articulates with ulna. So we have this joint known as the radiocapitellar joint. Now this is the joint formed between the head of radius and the capitulum of the humerus. We have coronoid fossa. This is a depression above the trochleus on the anterior surface of the distal humerus that accommodates coronoid process of the ulna during elbow flexion. So it's a depression. So this for this case, we expect that the other bone has something that projects from it. So the projection will eventually get into this depression, and hence have that during elbow flexion, there's no destruction of other bone site tissues. So coronoid fossa is just but a depression that accommodates the coronoid process of the ulna. Olecranon fossa is a depression on the distal posterior. Now this is found on the posterior surface that accommodates olecranon process during elbow extension. The other one was for the coronoid process, and for this other one, which is olecranon fossa, is for the olecranon. For the olecranon. So during elbow extension, olecranon is accommodated by olecranon fossa, and olecranon process or olecranon is found as well on the proximal aspect of the ulna. So on the proximal aspect of the ulna, we have this extension known as the olecranon, and we'll be able to check that on our next on our coming slides. So radial fossa is a slight depression found just above the front part of the capitulum that receives the anterior border of the head of radius. So this just but a fossa that receives the anterior border of the head of radius. We have the forearm, which marks as another bone of another part of the proximal of the upper limb bone. So the forearm, which is also known as the antebrachium. The forearm is made up of two bones, which is the ulna on the medial side and the radius on the lateral side, which are parallel to each other. So the ulna is significantly connected to the humerus and the radius. However, the radius on the other side contributes more significantly at the wrist joint than does the ulna. So it's opposite of the other. Ulna contributes significantly, it's connected to the humerus, while the radius now significantly connected to the wrist joint than the ulna. So let's check on these bones. We have the first bone, we have the radius and the ulna. As stated earlier, this is found on the medial aspect, and the other one is found on the lateral aspect. So this image was taken from the anterior aspect of the forearm. So we have, as well as other bones, we have the anatomical areas and the landmarks, the grooves, the projection, and the sulcus, whatever is now shape on them. So number one, we have the head of radius. This other side we have the radius, and the other side we have the ulna. Let's start from the radius. We have the head of the radius, and number two, we have the articular circumference of the radius as well. Then number three, we have the neck. Number four, we have the radial tuberosity. Number five, we have the shaft. Number six, we have the anterior surface of the radius. Number seven, we have the styloid process of radius. Then we have number 8 being the articular surface. And number 10, right here we have the ulnar notch. Notch is just but a depression, a kind of depression. We'll be able to understand more about that as we will proceed. Moving to this other side, on my right side, we have the ulna. Starting from number 11, we have the trochlear notch. Mark this area, the trochlear notch. We have number 12, the coronoid process. Number 13, we have the radial notch. Number 14, we have the ulnar tuberosity. Number 15, we have the head right here. We have number 16, the articular surface or the circumference, the articular circumference. Then we have number 17, the styloid process. Remember, both bones have styloid process on their distal aspect. Let's now proceed. We have this image was taken from the posterior aspect, and we are able to identify still the anatomical surfaces. Number 1, obviously the head of the radius. Number 2, we have the articular circumference. Number 3, we have the neck. Number 9, we have the posterior surface. Number 7, the styloid process. Moving to number 19, which is from the ulna, we have number 19 is the olecranon process. Just stop right here. Sorry. We have the olecranon process here. We have number 18, posterior surface. Number 10, we have the ulnar notch on radius. I'm sorry, I should have mentioned number 17, the styloid process. Yeah, we have this styloid process right here. So this is the elbow joint formed by the bones of the humerus and the bones, the articulating end of humerus and the articulating end of ulna and also the radius. So this is just about the elbow joint on the anterior view, the anterior aspect, can be able to identify the medial epicondyle of the humerus. We have the capitellum, and we have the radius, which forms the radiocapitellar joint, and we have this ulna with trochlear. In general, this just for anterior aspect of the elbow joint. We also have the posterior aspect of the elbow joint. We have the olecranon of the ulna. We have the head of the radius right there. We have the ulna and the humerus. This is the medial epicondyle, and that's the lateral epicondyle. Let's proceed with the discussion. Starting with the ulnar bone, the proximal end of the ulna articulates with both humerus and radius. So the proximal aspect is the topmost aspect. This articulates with both humerus and radius. So we have the anatomy, the trochlear notch, which we were able to identify, a distinct depression that articulates with the trochlear of humerus. So this trochlear notch is a depression, kind of depression. So this articulates with the trochlear of humerus that contributes to the formation of elbow joint. We have radial notch located on lateral and inferior to the coronoid process, and this area articulates with the head of radius. So the radial notch articulates with the head of radius. Coronoid process, this is a ridge of bone projecting outward and anteriorly, and then it forms the anterior lip of trochlear notch. I just need to go back and show you that stuff of the ridge of bone which I've just stated. So coronoid process can be easily let's check on this. So let's check on number 12. Number 12, we have a coronoid process and forms the anterior lip of the trochlear. Then we'll check on the olecranon, which forms the posterior lip of the trochlear notch. So let's proceed now. Olecranon, a large projection of bone that extends proximally and forms the posterior lip of trochlear notch. Triceps brachii attaches to its superior surface. As you can touch your posterior aspect of your humerus or so upper arm, can be able to feel the triceps muscles. And remember now, these muscles attaches to the olecranon of ulna. So that's the proximal aspect of ulna. We have styloid process, and this is the distal projection from the head of ulna. Just a distal projection, the head of ulna. Distal end of ulna articulates with ulnar notch on the distal radius and with the triangular articular disc in the wrist joint. So the head articulates with the ulna, is the distal end of ulna, which articulates with ulnar notch on the distal radius. So the distal radius has the ulnar notch, a depression whereby this head fits in. So moving ahead, we have the radius. The radius, another bone of the forearm. This is the long bone in the forearm that lies laterally and parallel to the ulna. So this now the bone that lies laterally. Medially, we're told is the ulna. Now the lateral aspect, we have the radius. Medially, ulna, lateral, and laterally we have the radius. So anatomy, we have the head of radius. Head of radius, a proximal disc shape that articulates with the capitulum of the humerus to form radiocapitellar joint, which is basic component of the elbow joint. Head is the proximal disc shape as stated. Then we have the neck, a narrow area of bone which lies between the radial head and radial tuberosity. So the neck is now the narrow area of bone distal to the head. Now, and lies between radial head and radial tuberosity. So it's proximal to radial tuberosity and distal to radial head. The radial tuberosity, we have a bony projection which serves as a place for attachment of biceps brachii muscle. So the biceps attaches to the radial tuberosity, while the triceps attaches to the olecranon of the ulna. Now, as you can be able to touch your anterior aspect of your upper arm, or the anterior aspect of your humerus, can be able to palpate or can be able to touch the biceps brachii muscle. Then remember they're attached to the radial tuberosity, which is found on the proximal aspect of radius. We have the ulnar notch, concavity on the medial surface on distal radius that articulates with ulna to form distal radio-ulnar joint. So this the notch, as I've been stating, is a concavity or a depression whereby it accommodates another bone or articular surface. So we have on the distal end of the radius has two facets for articulation of scaphoid and lunate. Scaphoid and lunate, these are the couple bones which makes up the wrist joint. So remember, stated earlier on, that the radius significantly articulates with the wrist joint than the ulna, while the ulna significantly articulates with humerus at the proximal aspect than the radius. So here we have the facet which articulates with the first two couple bone, which is the scaphoid and lunate, which makes up the wrist joint. We have the styloid process. This is a bony projection on the lateral side of the distal radius. So this now also the styloid process, just as the ulna has its own. So the styloid process of radius and ulna provides for lateral and medial stability of the wrist joint. So they're there for lateral and medial stability of wrist joint, so that they can be able to work that way. We have finally the hand, which is the manus. The hand is made up of bones grouped in three categories, starting from the carpus bones, metacarpals, and the phalanges. So these are the bones which makes up the hand. The hand now basically is the manus and has this group of bones: carpus bone, metacarpals, and the phalanges. Starting from the carpus or the wrist is made up of 8 sets of carpal bone that are arranged in 2 transverse rows of 4 bones each. So we have the 8 bones, then they are arranged in transverse rows of 4 bones each. We have now the proximal and the distal. Proximal row, naming from the lateral to medial, consist of, these are now the bones of the proximal row. Starting from the lateral, the area far from the body, or the midline, we have the scaphoid, lunate, triquetrum, and the pisiform. And the pisiform is the bone which is formed as a sesamoid within the tendon of the flexor carpi ulnaris. So pisiform, just as the patella, is also formed in the tendon and it's known as the sesamoid bone. And this, the tendon is of this muscle known as the flexor carpi ulnaris. We'll be able to identify this muscle when we'll be moving ahead to the discussion on the muscles of the body, but maybe not now. That will come to it will come in the near future. Since then, I'll be majorly dealing with bones, and this is what I'm doing right now. We have the bones of the hand, and with this image can also be able to identify the distal aspects of radius and ulna. So number 1, number 2, which is this, and number 1 is the radius, sorry, and number 16 is the ulna. So number 2, now we can be able to identify the ulnar styloid process right here, ulnar styloid process. Number 3, we have the scaphoid bone. Number 4, we have the capitate. We have number 5, the trapezium, which comes to this, sorry. Number 5, we have the trapezium. Number 6, we have the trapezoid. So this is the bones of the, these are the couple bones. We have the scaphoid number 3 right here. Number 4, we have the capitate. Number 5, we have the trapezium. And number 6, we have the trapezoid. This is just a random identification of this bone, but we'll be able to identify them on my next slide, whereby we have the proximal and the distal arrangement. Moving to number 7, we have this bone, which is the first metacarpal bone. So the thumb marks up with the first metacarpal bone. Then number 8, we have the second, fourth metacarpal bone. Fourth, fifth, sixth, and sorry, we have the second, third, fourth, and fifth, which are the metacarpal bones. We have number 9, proximal phalanx of the thumb. This is now the proximal phalanx. Then number 10 brings us to the distal phalanx of the thumb. We have the proximal, distal, the carpal, metacarpal, proximal phalanx, and the distal phalanx. We have number 11, base of proximal phalanx. So right here, remember this is the base now. This is the base. Number 12, we have the proximal phalanx, just as number 9. Number 9 is the proximal. Then number 12, you have the proximal phalanx of the second, third, fourth, and fifth. We have the proximal phalanx of the second to fifth phalanx. So this is the base. Then we have number 12, the proximal phalanx. Number 13, we have head of the second proximal phalanx. So this is the base, right here, the base, and here is the head. Base, head. So the base articulates with the metacarpal, and the head articulates with the middle phalanx right here. So this head articulates the middle, and we have the distal. We'll be able to know how this comes to function, because for the thumb case, we have just the metacarpal, the first metacarpal, then we have the proximal and the distal, but it lacks the middle phalanx. And for this case, for the second to fifth, we have the metacarpal, and we have the proximal and the middle, and finally the distal. So number 14, we told the middle phalanx. Number 15 is the distal phalanx. As I stated, number 16 is just but an ulna, that's ulna bone. Then number 17, we have styloid process of ulna, that's just for stabilization of wrist joint. Then number 18, we have the lunate bone. 19, we have the pisiform bone, can only be seen on the palmar aspect of hand. We have number 20, triquetral bone. Number 20 is right here. This is number 20, triquetral. We have number 21, which is the hamate bone. This is the hamate bone. 22, we have the humerus or the hook of hamate. It's just but a projection or a hook of hamate bone. Then we have number 23, which is right here. This is the base of third metacarpal bone. So right here, these are the bases of metacarpal, and for the identification of this, we have the base of the third metacarpal bone. Number 24, we have this. This is the head of intercarpal bone. This is the head. Yeah. Then we have number 25, finally, is the tuberosity of distal phalanx. Sorry if my pointer is misbehaving somewhat. So number 25 is the tuberosity of distal phalanx. This is the general, just another image just to mention. We have the carpal bone. On the proximal row, we have metacarpal here, identified as 1 on thumb, then second, third, fourth, and fifth. Then we have the phalanges of the digits. We have those bones. Proximal row, we have the scaphoid, we have the lunate, we have the triquetrum, and we have the pisiform, with the radius and ulna. Then we have the distal aspect. We have the trapezoid, the distal row. We have trapezium. Sorry, we have the trapezoid. We have the capitate. We have the hamate marking the final number. The dorsum aspect of the we have the same bones, but only for the pisiform could not be identified from the dorsum, just because of the anatomy of the hand. This just but a repetition of the same, the bones of the hand, but on the dorsum aspect. Scaphoid, lunate, and triquetrum. Pisiform is just found on the anterior aspect, and the rest are just as we had mentioned earlier. The distal row from lateral to medial consists of trapezium, as we have seen, trapezoid, capitate, and hamate. This now marks the distal row. Then we have proximally scaphoid and lunate articulates with radius to form wrist joint, while on the distal row, all carpal bones articulates with metacarpals. So proximally, they articulate proximally, the carpal bone articulate with the radius, which is the scaphoid and lunate articulates with the radius to form wrist joint, while on the distal row, all the carpal bones articulates to form articulates with metacarpal to form the metacarpal joint. So the joints, we'll be discussing them in another lesson. We'll be able to identify the joints formed by different bones. So metacarpals, the metacarpals of palm consist of 5 metacarpal bones. Each metacarpal bone consists of a proximal base, a body, which we've been dealing with on the previous image, and a distal head that is rounded for articulation with the base of each proximal phalanx. The medial and the lateral surface of the metacarpals are concave, allowing for attachment of interossei muscles. So they are concave. So these metacarpals have a concave shaft on the lateral surface, whereby it's for attachment of interossei muscles. They are numbered and each associated with a digit, just as stated earlier on. And the first one being the thumb, which is first metacarpal, the thumb on the thumb. Second, on the index finger. Then the third metacarpal is found on the middle finger. The fourth is found on the ring finger, and the fifth is on the little finger. The point of conclusion, we have the phalanges, and these are the bones of the fingers, and in singular form, it's known as the phalanx. There are 14 in number, of which are arranged in proximal row, middle row, and the distal row. The thumb lacks middle phalanx, as stated earlier on in the image shown from the above slides. So, in general, we have all as 14 in number. That marks the end of our discussion. And please bear with me with the little errors, which I'll try as much as to correct them. And if you're in need of slide, I'll give you the link to find them so that it can add value to your studies. Thank you, and please do not forget to subscribe.